Well, hello everybody. I'm sorry I couldn't be with you today. I hope you found the previous sessions useful. We're now going to be looking at it's not just pie in the sky, it's testing in the clouds. So to set the scene, the objective of this session is to demonstrate how Team Foundation Service, with Team Foundation Server 2012 at its core, Visual Studio 2012 and Azure can help any organization migrate not just their testing efforts, but their whole application lifecycle into the cloud. For the purposes of this demo, we're going to be taking an organization that is currently developing MVC-based solutions. This organization has been developing in Visual Studio 2010, but uses a file-based source control mechanism and also an Xcopy type deployment to their one and only test environment. In their test environment, they have one IIS web box and one SQL Server box. Currently, their test team manages their tests using Excel, and they execute all tests manually. They execute their tests using a browser on their own machines, pointing at the single shared test environment. Now, the test team is experiencing problems with working in a test environment where the developers are debugging and making ad hoc changes, which often invalidates most of their testing effort. The organization would like to use Team Foundation Server so that they can increase the quality of their solutions and therefore the satisfaction of their customers by implementing certain agile processes, such as continuous integration, automatic deployment, and automated testing. They do not, however, want to install, configure, or maintain their own Team Foundation Server infrastructure. They would also like to have more test environments and want to harness the power and flexibility that Azure could give them. But they don't really want to re-architect their solution for Azure at this current time. I'll be providing links at the end of this video for further information. For this organization, Team Foundation Service fits perfectly because it's effectively Team Foundation Server in Azure. We're going to assume that the Team Foundation Service is already created. First, we're going to create a project for our team to put all of their project assets. The first set of assets that we'll deal with is the source code. Here is our MVC solution running on the developer's machine. As you can see, it's a fairly basic web application with a number of menu options and also forms. Let's add this to Team Foundation Service by adding the code to our newly created project. Now we can check in our code so that it's uploaded to Team Foundation Service. And so here you can see the code exists in our project up on Team Foundation Service. Next, we're going to create a build. In this case, we're going to accept most of the defaults and kick off that new build. So while that's building, let's take a look at how we can move our test assets from Excel and into Team Foundation Service. As you can see, here are our test cases in Excel with titles, descriptions, and test steps. We also have an audit trail of the execution. We're going to use the TCM import utility from Codeplex. This can be used to help us perform the migration. We point it at our source test cases, select our Team Foundation Server, in this case Service, choose the project, complete some field mapping, data mapping. We will ignore links to any other work items for now and start off the migration. We can see the result of this process by starting up Microsoft Test Manager. selecting our Team Foundation service and viewing the newly created test plan that was created by the migrator. As we can see here, our test plan contains all of our test cases and organise them in a hierarchy ready for us to execute. If we look at one of the tests, we can see that also the test steps have been migrated for us. Notice also how we have our test plan results, which at the moment are not showing much in the way of progress, but we will revisit this later. So now we have our source code in the cloud. Let's take a look at the Azure Cloud Service that we've created, and this will form our new test environment. We have simply created 3 persisted virtual machines, one for the web server, one for the database server, and one to act as our test client. All 3 machines exist in one cloud service and are connected via a virtual network. Here we can see a set of remote desktop sessions pointing at each of the machines. The web server has IIS installed and also Web Deploy 3.0. This is so that we can easily deploy our application onto it. The test client is simply a machine that will be used to execute automated UI tests. Now that we've got an environment to deploy onto, let's look at how we can use Team Build to help us deploy onto that environment. There are many options here, but I have chosen one of the simplest mechanisms, which is a series of command line arguments for MS Build, which can be seen here. So we can add these to our build definition. At the same time, we will turn this into a continuous integration build. But for now, we're going to kick this off manually again. With Microsoft Test Manager, turning manual tests into automated tests is easy, and I'm going to show you how. But because this demo is short, I'm not going to be able to cover it in the detail that it rightly deserves. Now that we can see our solution has been built and deployed, we will run our test against that build using Microsoft Test Runner and turn action recording on. This will allow us to play back our tests later or indeed create coded UI tests from these recordings. Notice the actions being recorded as I am performing them, and also note how I am being very precise about performing the action and then passing the step. This will help produce a more maintainable coded UI test later. Let us save and close this, making a note of our test ID. Now to create our automated test. We need to start a new test project. We're going to cancel the wizard, but we'll start that again later. First, we'll rename our test file and test method so that they have meaningful names. Now we can use the wizard to bring our actions into our test method. The one thing missing from our action recordings is validation, so I will demonstrate how this is done by starting the application and getting to the page that needs to be validated. Then we use the Coded UI Test Builder to add the validation. We use the crosshair to pinpoint the control we wish to identify, inspect it and add assertions for the properties we wish to validate. Once we have done this, we can send that code back to Visual Studio under a method name and then finish our Coded UI Test Builder session. As we have done here, it is good practice to prove the validation by failing it first and then correcting it. In true Blue Peter style though, here is a suite of tests that I prepared earlier. These are working regression tests. Now before we check these in, let's suggest that one of our BAs has asked the developer to change the welcome message that a user receives when they're logging in. So we can make that change and check it in. This will trigger a new continuous integration build. Now we're going to put this all together by creating a build deploy test scenario. So while the build is running, we're going to associate all of our manual tests to their automated counterparts. We do this so that we can run our automated tests either at the end of a build deploy test scenario or directly from Microsoft Test Manager. Next, we need to create a build definition, as we did before, but this time we're going to choose the lab default template. This one I've customized slightly so that it can work with Team Foundation Service. I've included an extra parameter for lab drop share, and then we need to specify the parameters for the lab workflow. Set the environment name to the environment we're going to use, and we'll see that shortly in Microsoft Test Manager. Specify the build to use as our CI build. Add any scripts that need to be run to deploy to the environment. But in this case, it will be our test cases from the build to be deployed to an accessible location. Finally, we select our suite from our test plan and some test settings. Let's trigger our build deploy test scenario. And while that's running, we can keep an eye on our test agent machine so that we can see when it starts to execute tests. Let's take a look at the test environment definition in Microsoft Test Manager. As you can see here, it's our QA test environment, with all of our machines defined with their roles. But rather than looking at how to create a standard environment, we're going to take a look at the test settings, and this is where we're going to find all the great data and diagnostics that we can capture whilst running tests. So, in the test settings, we can see two specific test settings that are designed for automated test runs. The minimal diagnostic settings is not that interesting, but we're going to take a look at the one with full diagnostics. Again, we can see the roles that are involved and which role specifically is used to run the automated tests. In this case, the desktop client. When we get to the Data and Diagnostics tab, we can see that for the web server, we have turned on not just system information and the event log, but also IntelliTrace. IntelliTrace allows a developer to debug code historically, as if they were there at the point the test was executed. With Test Impact, all code paths exercised during the execution of a test are recorded. This allows Microsoft Test Manager to recommend tests that should be re-executed as a result of code change. This helps with the regression testing problem. It's fair to note though that this applies to both manual and automated test execution. So we don't need to capture quite as much information on the database server, but on the test client, we need to have the ASP.NET client proxy enabled so that IntelliTrace and Test Impact can work. Also here we can turn on video recording. Now all of this information is automatically added to any bugs that we raise as a result of any failed executions. Well, I hope you noticed the test client executing its tests as we were going through there. So now, let's look at the results of those tests. If we look with Microsoft Test Manager at the results, here we can see the details of the test run. We can see the detail of the failure, and of course, we can see the reason why it has failed. But it's likely now that we would like to rerun those tests to ensure that we can reproduce the bug. But this time, we're going to capture some more detailed diagnostics. So let's turn up the diagnostics and rerun. While that's running, it's worth mentioning that the reason we might not run with full diagnostics all of the time is because they come with an overhead, and so it can increase the time of your execution. Now that the test is completed, we can view the test results and raise a bug. Now it's up to our triage process as to how that bug gets dealt with. But as you can see, all of those diagnostic files that we talked about are attached to the bug, so the developer has the best chance of finding and fixing the bug. Let's take a look at the progress of the plan, and here we can see how it's tracking the progress of our plan for us. So in summary, what have we seen? Well, we've seen our source code being moved from on-premise into Team Foundation Service in Azure. We've taken our test assets from Excel and migrated them up to a test plan in Team Foundation Service as well. We've created a test environment in Azure Cloud Services, and we've deployed that code onto that environment. We've also created a build, deploy and test scenario, and that means that our tests can execute automatically. Finally, what we did is rerun our tests with higher levels of diagnostics so that we can debug our application. So here's the list of information that I promised earlier. And all that's left for me to say is thank you very much for finding the time to watch this video. I hope you found it useful. And of course, if there's anything that you feel you would like some further help on, anything that you've seen in this demo, then please do get in touch with us here at nFocus.